This is going to be a video defining various ways that we categorize numbers. It's not the only video I'm doing on that. Other ones, related videos, are in the panel down here, in the description underneath, and of course everything's categorized on the website as well. Okay, firstly, natural numbers. Natural numbers are just the numbers that we use when we're counting things. If children think of numbers, they will be thinking of the natural numbers. There's some debate as to whether 0 is a natural number. Won't worry about that. Basically, it is positive whole numbers. Okay, so I'll just put up here positive whole numbers. Straightforward, really. Can't go wrong with those. Integers are very similar. All natural numbers are integers. Integers definitely include 0, but they go further than that. They also include negative whole numbers, but the number must be whole. It can't have a fractional part or a decimal part. So these are whole numbers. I'll just put brackets, can be negative. So again, whole numbers, but we can have negative ones. Rational numbers, irrational numbers. Sounds a bit odd, doesn't it? I know you can get rational and irrational people. Believe me, I've met some. But rational in this case is not referring to that. It's referring to the first part of the word, ratio. And a rational number is a number which can be expressed as a ratio. Simpler to think of it as a fraction. If you can express the number as a fraction, then it's a rational number. This is a fraction with a whole number, an integer, as the numerator and underneath as the denominator. Sounds a bit complicated, but it's really quite simple. So this is basically any number which you can express as a fraction. Okay, so I'll put can be expressed as a fraction. I'll go over a few examples of these in a minute or two. Irrational numbers then, not surprisingly, are the opposite of rational numbers. These numbers cannot be expressed as a ratio or a fraction with one integer on top of another integer. There are such numbers, and when you put them as a decimal number with a decimal point, after the decimal point you have an endless stream of digits after the decimal point, and this endless stream of digits does not have any repeating patterns in it. And that is sort of a definition of an irrational number. At least that's what they look like when you see them, expressed as decimals. So as a definition of an irrational number, it cannot be expressed as that sort of a fraction. So cannot be expressed as a fraction. Okay, so we can't express these as a fraction, and when you put them as a decimal, you have this endless non-repeating sequence of digits. Non-repeating. Some rational numbers, you have an endless sequence of digits after the decimal point, but they are likely to be a recurring decimal where the same digit or the same short sequence of digits repeats over and over. Real numbers are essentially all of the above. Any of these are real numbers, and a way of defining a real number is to say that it has a position, it exists on the number line. A number line is a very useful concept in many aspects of maths, and I'll be covering it quite a bit in future videos. But if a number exists, you can position it between any other numbers. It is a number which exists on the number line, then it's a real number. So I'll put that. Pretty much everything you're likely to come across will be a real number. All of these things are real numbers. Of course, you may be wondering, what is the opposite of a real number? Can we have a pretend number? Well, we can actually have something called an imaginary number. And in certain branches of algebra, you come across equations which can only be solved by having a complex number, and a complex number has both a real and an imaginary part. But I'm not going into that. What I do want to do is just give a few brief examples of each of these. Natural numbers then are the counting numbers. Okay, so we've got 1, 2, 3, 78, 526, any number you like that is a whole number and a positive number. Some computer scientists or other scientists would include 0, but we're not going to worry about that. Integers are whole numbers, but they don't necessarily need to be positive, and you can definitely include 0 with integers. So integers will have a few numbers which can be negative, so let's have -7, -36, 0, 42, 7,281, whatever. They're all whole numbers. They don't have any fractions after them. They don't have any decimal points and bits after that. They're just whole numbers which can be negative. Rational numbers can be expressed as a fraction. Well, all of these can be expressed as a fraction. It's just 42 over 1, for instance. So all of these other numbers here are rational numbers, but they don't have to be whole numbers. Okay, so we can have -6. That is a perfectly valid rational number. We could have 0. We could have a half. We can have fractions which do not give an easy, simple decimal answer. If I have 1/9, that is in fact a recurring decimal if I write it out as a decimal. Nevertheless, it can be expressed as a fraction, therefore it's a rational number. Okay, let's have 43 over 47. Don't know what that is, but it's a rational number because it's one whole number over another. Okay. Irrational numbers we can't express like that. These are some of the numbers that you'll come across when you're doing maths, which are special numbers. When you do some circle work, you'll find that there's a number referred to as pi, which is an irrational number, 3.14159, etc. Goes on forever, and you cannot express it exactly as a fraction. So the number known as pi, written something like that, is an irrational number. There are various square roots and things which are irrational numbers. Quite a lot of square roots come across as irrational numbers. I'll put the square root of 2, root 2, as an example of an irrational number. Okay. Real numbers, rational numbers, irrational numbers, all of those things. So for that one, I'm just going to put all of the above, because all of these are real numbers. Okay. Okay, now as I mentioned right at the beginning, there is at least one other video defining words which we use to categorize numbers, and a lot of these things you do really need to know because they crop up all the time when you're looking at numbers, when you're doing other kinds of calculations. Yes, it has to be an integer, it has to be a rational number, it's an irrational number, whatever. So if you don't know what those terms mean, that could be a bit of an issue, so pop back and have another look through this one if you need a quick refresher.